All right, so we're reviewing for summative number 4, and I'm thinking everything on the summative has a new score coming your way. I'm pretty sure everything has a new score. So, no repeaters. Let's go ahead and solve. These are our and or questions, and you have to remember that when they're absolute value inequalities, you first must isolate. Oops, that is not how you spell isolate. So you must isolate the absolute value bars. Don't just look at the original problem and assume you know if it's an and or an or, because it depends on once you've isolated. So isolate the absolute value, and then you're going to set up two problems. So, isolating our absolute value, I'm going to start by adding this 9 over, which, if you don't mind, I'm going to just kind of write over here. So adding 9 to both sides, you still have the absolute value of 5x minus 4, still a less than or equal to, and then if you add 9 right here, you have a positive 6. So now that we are isolated, I can see that this isn't a less than question for an absolute value, which means we have an and. So when you go to set up your two problems, you set them up as, the first one's easy, you just take off the bars. So 5x minus 4 is less than or equal to 6. Write down the word and. The second problem, a couple things change. It's still 5x minus 4, but now you're going to reverse the sign, and then you're going to negate the answer. So you're going to solve both of them the same way. You're going to add the 4. So here you have 5x less than or equal to 10. Oops, that's a 10. And here you have a 5x is greater than or equal to, if you add 4 over here, you get negative 2. And then finally you're going to divide by 5 everywhere, and you get, x is less than or equal to 2. And make sure that word is there. X is greater than or equal to negative 2/5. So I was silly and I should have wrote this on the line that they provided me. The inequality solution goes right there. Then we're going to graph. Make sure the numbers go in relative numerical order. Negative 2/5 would come first. And then 2 would come after that. And think about it in your head what an and should look like. It should be in between the two numbers. So I'm going to go greater than or equal to negative 2/5 and less than or equal to 2. So that's exactly what I thought the and would look like. Now we're almost home free. The interval for ands are super easy. You just go from left to right. So negative 2/5 to 2 with brackets. Alright, this next one. A lot of kids at first think that it's a less than, meaning it's an and, but we aren't isolated yet. So you have to start by dividing by negative 4 on both sides, which actually give you a brand new question. It's now the absolute value of x plus 2 is greater, because you divided by a negative, so it's greater than 5. So when you go to set up your two problems, I now see it's an or. So you have x plus 2 greater than 5, or the second one, you flip the sign again, so now it's back to less than, but now it's a negative 5. So all inequality rules still apply when you're isolating, so you still have to flip your sign when you divide by a negative. And then when you go to solve this, I'm going to subtract 2, and down here I'm going to write down x is greater than 3. Make sure the word or is here. X is, oops, come on pen. It's the end of the day, my pen does not want to work, just like me. Alright, here we go. X is less than negative 7. So I know what I think an or should look like. An or should be, kicking out to the sides of the numbers. So unless I have one of those weird special cases, I got to pay attention to that. Negative 7 would show up on the number line before the 3. And I'm graphing everything greater than 3, so that'd be like this. Or less than negative 7, that'd be like that. Alright, here goes my interval, and that's exactly what I thought the graph would look like. So it starts from the left. So it starts at negative infinity, goes to negative 7 with a parenthesis, and then a union symbol, and then goes from 3 to infinity. You guys did fabulous on your interval notation on the last test, so keep it up. Alright, again, we're not isolated yet. So I'm going to start by adding a 9, and then eventually dividing by 4 as well. So 4 times the absolute value of x plus 1 is greater than or equal to 12. Still not isolated. Divide everything by 4. Now this time I don't flip the sign when I'm setting this up because it's not negative. I'm very sorry if that was loud. So our new problem is the absolute value of x plus 1 is greater than or equal to 3. Now let's set up our two problems. So it's greater than right now at this step, which means it's an or. So we're going to set up x plus 1 is greater than or equal to 3, or x plus 1 is less than or equal to negative 3. So remember, you flip the sign and negate the answer when you set up your second problem. Flip the sign, negate the answer. All right, we're solving. We're going to subtract 1, so you get x is greater than or equal to 2. Or subtract 1 over here. X is less than or equal to negative 4. Negative 4 shows up first on the number line. Watch your order. I'm going greater than or equal to negative 2, so like this, which is exactly what I thought the OR should look like. Less than or equal to negative 4. All right, here we go, from left to right. Negative infinity to negative 4 with a bracket. And then join that, so a union symbol, with 2 to infinity. And infinity has a parenthesis always, but that 2 has a bracket. All right, again, you got to isolate before you can set up your two problems. So I'm going to subtract 2 first. So I'm going to write 9 absolute value, x minus 7 is less than 18. And then cut everybody by a 9, both sides. So my new problem is absolute value of x minus 7 is less than 2. So I can see at this stage it is an AND. So we're going to set up x minus 7 less than 2 and x minus 7, flip it, greater than negative 2. It's a negative right there. All right, add 7. So x is less than 9. And adding 7 here, x is greater than 5. Make sure the numbers go in the right order. I know I keep stressing that, but it's a big issue on tests, so be careful. I'm going less than 9 and greater than 5, so that would be in between 9 and 5, which is exactly what we thought AND should look like. And I love AND intervals because they're so easy to write down, just left to right, parenthesis, 5 to 9. Awesome. All right. Oh, exponent properties. Now you notice we skipped over just regular old exponent properties, and here you just have rational exponents. And that's how you're going to be tested. So yes, you still have to know exponent properties, but we're going to bump it up for Algebra 2. You have to know how to do fraction exponents, and we know they're the same property, so that's not a big deal. So 3 rules. You have to have no parentheses in your final answer. You can't have negative exponents, so I'm going to write this down. So no parentheses. My second rule is final answer can have no negative exponents. And then the third rule is you need to combine all terms. So don't stop simplifying until you get to that point. Alright, just be careful on this first one though. 6 and 4, those are coefficients. They do not follow exponent rules. So 6 times 4 is just 24. I don't have parentheses to worry about, but I do have some combining I have to worry about. So I have x to the 3/4 and x to the 2nd. And remember, when you're multiplying your bases together like this, you're supposed to add your exponents together. So that becomes, alright, let me think about that. It's what, 8/4? So 3/4 plus 8/4. What did I just say? 3/4 plus 8/4 is 11/4. If you do not want to do that in your head, I don't suggest you try it. Go ahead and take 3/4 plus 2 and then hit math enter on your calculator. And then same thing here with the y's. You're going to try to combine them. So we need to add their exponents as well. Let's see here. Y to the, oh boy, let's see, negative 7/6. Instead of plus 1/3, I'm going to call that 2/6. So that, ew, negative 5/6. We're still not done. This is terrible news. Remember, no negative exponents. So the negative exponent term needs to move to the other side of the fraction bar. So final answer, 24 x to the 11/4 over now a positive y to the 5/6. There's our final answer. Ugh, yuck. All right. This next question, same idea. Coefficients. Take care of them first. 7 times 2, better known as 14. And then, let's see, I bet it's a similar problem here. X to the 3/5 times x to the negative 2. We're going to need to add those exponents together. Please just use your calculator if you don't want to do mental math on the, or by hand action, adding fractions. There we go. And we're adding to that a negative 2, which is like a negative 10/5 if I got common denominators. So 3 plus negative 10 is a negative 7/5. Oh boy. Now I'm not checking my work, so there's a good possibility that I'm just messing up right and left, so I apologize. If this was a test, I would be checking this on my calculator. Alright, here we're going to add negative 7/2 and 5/3. So I'm going to get common denominators here of a 6. Oh boy, let's see, negative 21/6 plus 10 over 6 to get common denominators there. So what is that, negative 11 over 6? And again, anything that has a negative exponent needs to move. So the y is going to move and the x is going to move. Please don't stress about the fraction arithmetic. If you're not sure how to do it, just type in your calculator. Really, it's not worth your stress. Alright, this becomes x to the 11 over 16, positive this time, and then y to the 7 over 5, positive again. My only exception to that calculator rule would be is if you know in your near future you need to take like an ASVAB test or something where you can't use a calculator and you got to brush up on your skills. So in that case, on your test, I want you to try doing them by hand and then double check on the calculator to make sure you get a good score. Alright, here, we're going to distribute and multiply these exponents together. So, this is obviously still an x, but negative 5 times, I can't even read that anymore, negative 5 times 5 fourths, so negative 5 times 5 fourths would be negative 25 fourths. Gross. Alright, and then y to the, and here we have 1/3 times 5 fourths, which would be 5 over 12. And same rules as before, guys. We cannot have negative exponents in our final answer, so the negative exponent term will move. So y to the 5/12 stays up in the numerator, and now you have x to the 25 fourths in the denominator. This is also my plug for making sure that your exponents, mine are getting kind of out of control there, your exponents are up top in the superscript, and they should be kind of small in relative size to the bases. Alright, 4b, you can still think of it as distributing. The other thing you can think of is anything to the 0 power is a 1. So this term right here is really just a 1, which means it doesn't do anything to the problem, so I'm literally going to ignore it. So it's not that it's 0, the term is 1 and therefore negligible for the problem. So now I have just a power to a power, and I just got to multiply them together. So multiplying 6/5 times 7/3. If I had to do that by hand, I'd probably do a little cross-canceling here. These are both divisible by 3, huh? So that's 14 over 5. So this is y to the 14 over 5. Whew, nice and messy. Alright. Again, I cannot reiterate this enough. You do not have to do the fraction operations without a calculator. Be careful on this next one because there are no parentheses, so there's nothing to distribute, but everybody gets messed up right here. These are not exponents, these are coefficients. So I just need you to reduce them by dividing them and then hit Math Enter Enter on your calculator. So if I reduce these both by 5, I get 3 over 5. Now you can use your exponent rules. So when I'm dividing these x's here, I'm going to subtract. And then you're going to do the same thing here with the y's. You're going to subtract. So I'm going to be honest, guys, I am stinking tired right now, and even your math teacher's given up on doing these fractions by hand. So 6 minus, careful, a negative 2/5. So when you type that on your calculator, make sure you're typing 6 and then minus the negative 2/5. You got that double negative thing going on here. So that becomes x to the 32/5. Practice typing that, please. And then negative 2 minus 8/5 is negative 18/5. So, please practice typing those if you plan on using your calculator on the test instead of your brain. I do not blame you because it's a test. But remember, anything with a negative exponent needs to move. So final answer, 3 is still up top, x to the 32/5 is still in the numerator. But now you have a 5 and a y to the positive 18/5 in the denominator. Alright. Gross, huh? I totally made these up like on the fly, and I can't promise they'll look nice at the end, so sorry. Alright, remember you're trying to reduce the coefficients. 7 divided by 9, if you tried to reduce that, you wouldn't have a lot of luck because it does not reduce. So you're going to keep your coefficient as 7 over 9. And then the same property is being used as the previous problem. So you're going to subtract your exponents here. So 3 halves minus a negative 2/5 Again, I'm tired. I don't want to think anymore. Tapped out for the day on my math. And I got 19/10. So this is x to the 19/10. And then here for the y's, 6 minus 11/2 is positive half. So this is y to the 1/2. And no one can read what I wrote here, so let me try that again. Oh, it's like it gets worse every time. There are no negative exponents, so we're actually good. Leave it. Alright, next question here. You got a little distribution action going. This 1/2 power needs to distribute to all the other terms, and it's going to multiply. So you are distributing and you're multiplying into there. Now, don't forget about this x to the 1/5 out in front. He's just going to kind of hang around for a minute. But for these next couple terms, this becomes x to the 2 times 1/2 is 1. And then 5/2 times 1/2 is 5/4. So you took care of the distribution, the parenthesis issue, but now you're going to have to combine your like terms. Remember our rules here? We're supposed to add the exponents. That one I think I might be able to do in my head. Let's see. 1/5 plus 1 would be like 1/5 plus 5/5. So that is x to the 6/5. And then y to the 5/4 doesn't combine with that because it's a different base. So if I go through my little checklist, nobody's negative, there's no parentheses, and I combined all of the like bases. Alright, same idea here. You're going to distribute and multiply, but be careful that you are distributing to everybody, including that 7 up there. Now this x to the 2/5, just kind of hanging out for a minute. 7 squared. You can write it as 7 squared, but I'm going to go ahead and call that a 49. And then here we got to multiply the existing power. So negative 2/5 times 2 is negative 4/5. And then 7/2 times 2 is 7. And again, we're not done because we have some like terms we need to collect here and here. We're going to need to add these together. So I'm going to write 49 first. Oh boy. 2/5 plus negative 4/5. Oh, this is terrible news, guys. We're not going to be done yet. This is x to the negative 2/5. And then y to the 7. And you see why we're not done, though? This negative exponent term, this guy right here, is going to have to move to the denominator. Now, of course, I'm out of room, so I'm going to go over here. So the 49 stays where it is, the y to the 7 stays where it is, but now the x to the 2/5 will be in the denominator, and now it's positive because we moved it. Sorry about the messiness there. I'm going to extend this page. Oh, I don't think I need to. Favorite problem on the whole planet. Anything to the 0 power is 1. So this says x to the 3rd times a 1. My answer is x to the 3rd. Oh, even better problem. Look at this. The whole thing is raised to the 0 power. The answer is 1. I swear to goodness, if you get that wrong on the test, I'm going to put the biggest frowny face I can come up with. Alright. Here's some more new stuff. Writing from radical form to rational exponent form. So remember the property says that you have a radical symbol, and over here this is called the index. So whatever number is in the corner there is the type of radical, and then outside or sometimes inside the radical there is a power or an exponent. The rule is if I'm changing this back to exponent form, you keep your base whatever it was. The base is the thing that's inside. But then the way you rewrite it, it's going to be the power divided by whatever the index number is. So this guy here, the base is a 2b, so I'm going to write down 2b as in my base, holding up my new exponent here. The power is a 4, and I'm supposed to divide that by the index number, which is this 5 here. So 2b to the 4/5 power is what they want to see for that answer. It's a really easy question once you know the formula. So here, the base is an m. You don't have to put parentheses this time, but you can. The power is 7. They can write it in or out of the radical. It's kind of cool like that. And then you're going to divide it by the index, the type of root, which is the 9th root. Good, good. So this is a little tricky for kids because they complain that they don't see an index. Well, when you have a square root symbol, which is what we call square root, and there's nothing in the index, we assume it's a 2. There's no such thing as a first root, so a square root is the smallest root that you can get. So the base in this question is an xy. This time you do need parentheses. The existing power is a 9. And you're going to divide it by the index, which is a 2. Alright, and this last one here, the base is an AB. This one's tricky because it doesn't seem to have a power, but we know there's always a first power. So I'm going to put a 1 there. And then again, the index is a 2, even though they didn't write it. They'll never write a 2 for a square root. You have to know that when you see a radical with no index, it is a square root. Alright, here we go. Go in the other direction now. What I usually do is I write the radical symbol and I immediately put down the index number because otherwise I forget. So radical symbol, and I know that the index is this 5 here, so that goes right here in the corner. The base is the x, and then the power, it is up to you where you put the power. You can either put a 1 here or you can put a 1 outside the parentheses, but since it's a 1, you really don't need to put it down at all. Alright, here, radical, but it is a square root I see. So if you want, you can go ahead and put a 2. You don't have to though, and it's not wrong if you leave it off. It's actually better if you leave it off. Base is b, and all of it's being raised to the 5th power. So I would accept this answer. I would accept just a radical symbol, so I know it's a square root with the 5th power inside. You could put the 5th power outside of that. I mean, there's all sorts of answers. There's like 4 different answers you can give me, so your choice. Alright, same idea here. This time it is the square root, so you're welcome to put a 2 here, but I'm not going to. I can see the base is 5y. And then I always like to put the powers outside. It's up to you. I really don't care, guys. I'm flexible with your answer choice, as long as you know they're equivalent. Alright, 4th root. So we'll put a little 4 in the corner for the index. The base is mr. And we're raising it to the 1st power. So you actually don't have to raise it to anything, but you can. You can put a 1 there if you want. I'm not going to count it wrong. Sometimes it's nice to have a little consistency when you're doing this because it develops muscle memory. So up to you. Alright, now we're simplifying radicals. So these are both square roots. There's nothing in the index, so we assume it's a square root. And we need to be reducing radicals. So we're going to break them up into pieces, basically. There's a couple different ways we've shown you these problems, and what I like to do is break up term by term. So 32 is not a perfect square, but 16 is a factor of 32 and is a perfect square in itself. So I'm trying to think the best way that you guys liked. Okay, I'm just going to expand it out. Here we go. A couple of different ways we broke out 32, but I'm going to go with 16 times 2. And then for x to the 4th, I'm just going to leave it as x to the 4th. For y to the 7th, what I'm going to have you do is I'm going to call it y to the 6th with 1 left over, because that's a way to get 7. And then for z to the 2nd, because it's even, I'm going to leave it as z to the 2nd. So remember how there's a 2 here? Now it's a game of who simplifies and who doesn't. So you can take the square root of that guy, this guy, this guy, and this guy. When those numbers come out of the radical, the square root of 16 is 4. The square root of x squared, remember we divide these, is x squared. Or the square root of x to the 4th is x squared. The square root of y to the 6th, you divide these, is y to the 3rd. And the square root of z squared, when you divide these, is z. So now you have to tell me who's left in the radical. So the 2 is still there, and this other extra y is still there. There we go. That's what I need to see. Okay. I'm going to show this problem another way that we've maybe set up the problem, and you decide what method you like. So I'm going to break all the pieces into their own radical. Okay. So if I look at 48, I know that's the same thing as 16 times 3. I'd break that down, that radical. A to the 3rd I'm going to break down into the a squared times a. B to the 10th I'm not going to break down at all because it's going to go evenly. And c to the 1st power is going to be stuck. So when I look on this first radical, the thing that's going to come out of the radical, or twin jail, or whatever you want to call it, the square root of 16 is 4. But the 3 is stuck in the radical, so I'm going to leave it there. Taking the square root of, hello buddy, taking the square root of a squared, the a is going to hop out, but this extra a is stuck. And then square root of b to the 10th is b to the, whoops, hello, this guy right here, the square root of b to the 10th is b to the 5th, with nothing left over. And then since c couldn't reduce at all, he's just stuck inside the radical. So that's another way to reduce the radicals, like one term at a time. I think I prefer this method technically, so it's up to you. These are tricky. These can get really tricky. Alright, now be careful. 13, a and b switch to cube roots. So you have to think about the cube roots, which means things that are in our perfect cubic list are things we can reduce. And also things that divide evenly by 3. So like 8 is a perfect cube, so I'm going to leave 8 as it is. And then a to the 4th, if I peel one of them off, so if I call it a to the 3rd with that leftover a to the 1st, that's the same thing as a to the 4th. And then 15 will divide evenly, so I'm going to leave that as b to the 15. So, here we go. Things that reduce are, come on buddy, oh my goodness. I swear if my tablet stops working right now I'm going to cry. Alright, we're going to cube root that, we're going to cube root that, and we're going to cube root that. So the only thing that's going to be stuck in my radical, whoops, wrong color, is this guy. He's not going anywhere. Alright, so let's go ahead and write that down. The cube root of a to the 1st, stuck. But let's simplify everything else. Cube root of 8 is 2. Cube root of a to the 3rd is a. Cube root of b to the 15 is b to the 5. Remember, we just divide those over and over and over again. Alright, same idea here. Things that can reduce, let's do it, otherwise leave them. So 216 is a perfect cube, leave it. X to the 6 will reduce beautifully, leave it. 21, beautiful, leave it. Oops, that's a y. And then z to the 15, perfect, leave it. So everything reduces, we're not going to have any radical left. Cube root that, and that. Here we go. Cube root of 216 is 6. Dividing these guys, you get x squared. Dividing these guys, you get y to the 7th. And dividing these guys, you get z to the 5th. There we go. And notice I don't have a radical because there's nothing stuck in the radical. Those are really tricky. So don't be alarmed if it doesn't go well for you. We're probably going to have to retake that section and see it again. Alright, give an example of a set of points that is a function. So the idea of a set of points being a function, you don't have to use the set brackets, but give me a couple ordered pairs, maybe 3 of them. How about 3? It doesn't really matter, just more than one ordered pair. And I'm going to go 1, 2, 2, 3, and 3, 4. The reason this is a function is because every x is paired with only one y. So what is the domain? You're just going to list your x values. This is not a continuous function. So if you want to get real fancy, you can put set brackets. But you'll list out 1 and 2 and 3. All of the x values. And then for the range, you're going to list out all the y values. So 2 and 3 and 4. You don't really, it doesn't matter what order you go in. I like to put them in numerical order. Alright, so this question is the reverse of that. Still a set of points, but show me something that would not be a function. So let's say I had like 5, 2, and then like 4, 1, and then like 5, 7. The reason this is not a function is because of this x right here. X equals 5 is paired twice. So for your explanation, you can say x equals 5 has 2 output values. Now, if you wanted to get real specific, you could tell me what they are. You could also say x equals 5 has 2 y values or is paired twice. Those are all acceptable. Let's talk about the domain, though. You can still give me that. I see a 5 and a 4. Okay, so that time I didn't go in any order. Sorry about that. And then for our range, our y values, 2, 1, and 7. So again, order doesn't technically matter, but I'm going to go in numerical order this time. Go me. Good, good. All right, draw an example of a function. Make sure it passes the vertical line test. And it could be anything, so I'm going to go like, boom. Okay. It got really ugly real fast. So the domain goes forever left and right. So I'm going to say it goes from negative infinity to infinity. And the range is from, remember, low to high. So it starts down here at, I'm going to pretend it started at -3 with a point, even though I drew it really terrible. But then it goes up forever. So it starts at -3, and then it goes up, 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 up forever. And then it says create any function to make sure it passes the vertical line test that has domain. Oh, look what I did. That was really dumb. All right, back up. I'm going to make a new one. I did one that was going to work for the last question there, so let's do something crazy. I'm going to do an ultra boring question. Here we go. There we go. There's a function. The domain goes from -3 to 4. And then the range, always from low to high. So the lowest it is -3, and the highest it goes is 3. So make sure you are going left to right for domain, and make sure you're going, whoops, low to high for range. Or bottom to top, however you want to think of that. Alright, so here, any function that goes forever left and right, and then starts for a range at -3 and goes forever. So what if I used that little guy? Boom, like that. That would work, right? I guess I was like super psychic when I came up with that first one. Alright, there's some tricky stuff on this test, guys, so let's pause for a moment and really study this one and do the best we can. I realize it might take you a retake on a section or two, especially if you haven't been keeping up with our homework. This is going to be a challenging test, so let's be a lesson to you. Stay up on the homework. Good luck.